So we're going to look at how we can use the chain rule for some more complex questions. So here we have to differentiate, and we have two functions. We have 2x plus 1 to the fifth, and we have x cubed minus x plus 1 to the fourth. So what we really have going on here is we have the product rule, right? We have two functions. We have the first function, and I'm going to call that a, and we have the second function. I'm going to call that b. So I'm originally going to start by taking each of these and finding their derivatives. So a itself is just the first function, which is 2x plus 1 to the fifth. I'm then going to take a prime. So the derivative of a, I need to use the chain rule here because I have a function within a function. So the derivative, I'm going to do the outer function, which is something to the fifth. So it's going to be 5, 2x plus 1 to the fourth, times the derivative of the inside, which is 2. I'm going to do the same thing for my b function. So b is just what it is, so x cubed minus x plus 1 to the fourth. And then I'm going to take the derivative of b. So b prime, again, I'm going to use the chain rule. So I'm going to have 4x cubed minus x plus 1 to the third times the derivative of what's inside, which would be 3x squared minus 1. So since my overall y equals function is using the product rule, what I'm going to do is do the derivative y prime, and it's going to be the first, which is a, so 2x plus 1 to the fifth, times the derivative of the second. So the derivative of the second is this b prime. So what we're really doing is like we're multiplying a times b prime, and then we'll multiply b times a prime. So we're sort of like doing like a weird type of multiplication. So I'm going to multiply this by 3x squared minus 1 times 4x cubed minus x plus 1 to the third. So that's just the first times the derivative of the second. So then I'm going to do plus the second, which is x cubed minus x plus 1 to the fourth, times the derivative of the first. So I'm going to multiply 5 and 2. So I'm going to get 10 times 2x plus 1 to the fourth. So this looks a little bit crazy. So then what I'm going to do here is I'm actually going to try to factor out something that is useful because this looks very crazy and I don't want to have to multiply this all together. So I can look at what's in common with everything. So if I look at each side, so I'm just going to kind of underline this piece and underline this piece. So on each side of the addition sign, I want to look to see what they have in common. So on the left side, if I'm looking at in terms of constants, in terms of numbers, I have a 4. And on the right, I have a 10. So if I'm pulling out a GCF, if I'm trying to factor this, I'm going to pull out a 2. So that 2 is going to come out. I'm going to also look for common factors. So I have this 2x plus 1 to the fifth, and I have 2x plus 1 to the fourth. So the greatest that they would have in common would be a 2x plus 1 to the fourth. And then I'm going to look and I see this x cubed minus x plus 1 they both have. So here it's to the third, here it's to the fourth. So the most that they would have in common is the x cubed minus x plus 1 to the third. So that's my GCF. So I'm going to have pulled that outside. And then I'm just going to see what I'm left with. So I'm just going to put like a big bracket here. So looking on the left side of the addition sign, what do I have left? Well, I took out a 2 and there was a 4. So I do have a 2 left. The x plus 1 to the fourth came out, and I have 2x plus 1 to the fifth, so I need another x plus 1. And then there was this, the x cubed minus x plus 1 came out the whole thing. And then I have this 3x squared minus 1 left. So I'm just going to do 3x squared minus 1. Okay, so then I'm going to put the plus sign. And now I'm going to look to the right side. I took out the 2, and I had a 10, so I need a 5. The 2x plus 1 to the fourth, I took that out exactly. And then the x cubed minus x plus 1 to the third I took out, and I had it to the fourth. So I have one more x cubed minus x plus 1 that's left over. Okay, so then what I'm going to do is I'm just going to like foil this piece together, and I'm going to distribute the 5 into this piece. Let me just change colors here. So y prime, so my GCF is staying the same. I'm not doing anything with that. So I'm just going to leave that alone. Okay, so again with simplifying and stuff for the AP exam, if you got to y prime as this green step, okay, on an open-ended, that's correct. Okay, but again, if you have a multiple choice question, you're going to see it fully simplified. So we're going to keep simplifying it just so we can see what that's going to be. So this is exactly the same. And then I'm just going to put this big bracket. So if I FOIL like this all together, this is going to end up giving me 12x to the third minus 4x plus 6x squared minus 2. And then I distribute the 5, so 5x cubed minus 5x plus 5. And then I'm just going to combine like terms together. So again, I'll just switch colors here. Y prime equals, my GCF is staying the same. Didn't do anything with that. Oops, that should not be a 3 there. It should just be an x to the third. So x to the third minus x plus 1 to the third. And then when I combine all my like terms here, I'm going to have 17x to the third plus 6x squared minus 9x plus 3. So here's our final answer. It's sort of complicated, but not really. So all we're doing is we're using the product rule, but we're combining it with the chain rule. Kind of gets out of hand. We're looking for our common factors to pull out of both sides of the addition sign, and then we just try to simplify what we have left. So the reason that we call it the chain rule, it becomes clear when we make a longer chain by adding another link. So suppose that y is equal to f of u and u is equal to g of x and x is equal to h of t. So we're throwing in another variable where f, g, and h are differentiable functions. To compute the derivative of y with respect to t, we have to use the chain rule twice. Right? So in this example, we have like dy over dt is equal to dy over dx times dx over dt. But if we're adding another one in, we have that dy over du equals du over dx times dx over dt. That's using Leibniz's notation. So I'm going to just use that first one that we used in the previous video for the chain rule, and we'll just kind of see how this works. You're just kind of thinking about using the chain rule like a blow pop. Okay, so if you've ever had a blow pop, right, we know that you've got the wrapper on the outside, like the farthest outside is the wrapper. Once you open the wrapper, you have the lollipop. And then once you eat the lollipop inside, you have the gum. So there's the wrapper, the lollipop, and the gum, and one's inside of the other. You can also think about it as like nested dolls, if like one's inside of the other. So what we're going to do is just first kind of rewrite this so we know what function is on the outside. Since we have sine cubed of this thing, we know that it's the same thing as saying the entire thing cubed. So I'm going to rewrite this and do y equals sine of x squared plus 4x to the third. So I want to look for my wrapper in this case, the outermost function. So my outermost function is something to the third. Then the next piece, the next inside piece, which would be the lollipop, would be the sine of something. And then the gum, the innermost piece, would be the x squared plus 4x. So you're always going from like the outside in. So if I wanted to find the derivative, y prime is equal to, so I'm going to take the derivative of the outer, so it's going to be the 3 sine of x squared plus 4x to the second, and then I'm multiplying it by the derivative of the sine of x squared plus 4x. Okay, so I'm just going to go from there. So I'm just writing it down in each step. So I had that outer one already done, so I'm just rewriting this. So now when I go to take the derivative of sine of x squared plus 4x, I'm doing the derivative of the outer. So in this case, the outer is sine. So that's going to be cosine of x squared plus 4x. And then I'm going to multiply this times the derivative of x squared plus 4x, because that's the farthest inside. So then I will, again, just following the steps, I have 3 sine of x squared plus 4x squared times the cosine of x squared plus 4x times, and I'm multiplying the derivative of x squared plus 4x, so that's going to be times, 2x plus 4. Okay, and this is my derivative. So you always start with the outermost function, and then you just multiply it by the derivative of the inside. And then if that one still has a function on the inside, you multiply by the derivative of that inside. So you just keep going and going and going until you run out of derivatives to take. Once you get to the derivative of this, there's no inner function anymore, so then we're done. Okay, so let's look at another example. Find f prime of x if f of x is equal to the sine of the cosine of the tangent of x. Okay, so always look on the outside. So here again, our wrapper would be the sine function. So we're going to do the derivative of the sine. So that's going to be cosine. And then we're going to do it at the inner functions. So cosine tan x. Okay, then we're going to multiply it by the derivative of what was inside. So the derivative of cosine tan x. So I go to my next step. So f prime of x is equal to, so this is going to stay cosine tan x. And I'm multiplying it. So the derivative of cosine tan x, I'm going to do the derivative of the outer, so the derivative of cosine. So that's going to be negative sine of tan x times the derivative of what was inside, which is tan x. So then I've got f prime of x equals cosine of the cosine of tan x times negative sine of tan x. And then the derivative of tan x is secant squared x. And then we've run out of derivatives to take because there's no more interior function. So I'm just going to rewrite this with the negative in front, because when I have a negative sort of like in the middle, it looks like it's subtraction at some point. So I'm just going to put the negative right in front, and I'm just going to say it's negative cosine of tan x times sine of tan x times secant squared x. So the more interior functions you have, the longer your chain is going to be. So you could have like 100 of interior functions, and then just is going to keep going and going and going until you get all of the derivatives of all the inner functions. Okay, we're not going to do 100, but just know that you can do as many as there is. Okay, differentiate y equals e to the secant of 3 theta. So y prime. Okay, our outer function is e to the something, so it's going to be e to the secant 3 theta times the derivative, so d over d theta, derivative with respect to theta, of the interior function, and in this case, the interior is the exponent, so the derivative of secant 3 theta. So we've got y prime equals e to the secant 3 theta times, so I'm taking the derivative of secant 3 theta. So that's another chain rule. The secant is the outside, the 3 theta is the inside. So the derivative of secant is secant tangent. So we're going to have secant 3 theta tan 3 theta times the derivative of 3 theta. So we've got y prime equals e to the secant 3 theta times secant 3 theta tan 3 theta. And then the derivative of 3 theta is just going to give us 3. So just to kind of clean it up, I'm going to put the 3 in front. So I have 3 e to the secant 3 theta, secant 3 theta, tangent 3 theta. And here's my derivative. Oops. So now we're going to look at a couple of like abstract ideas where it's not just here's the function, find the derivative. So here we have f of x, which is our main function, and it's equal to f of 3 of f of 4 of f of x, which is kind of a mouthful, where f of 0 is 0 and f prime of 0 is 2. And we want to find capital F prime of 0. So this might seem confusing, but it's just the chain rule. Okay, so we have f prime. So I'm going to do it without the 0 first. So I'm just going to do f prime of x. So if this is my function, right, the outer function is f. So I'm going to do f prime, the derivative of f, at the inner function. So at 3 f of 4 f of x. Okay, and then I'm multiplying that by the derivative of the inside. Now the derivative of the inside, right, here is the inside. So the outer function is the 3f, this thing. So 3f is the outer function. 3 is the constant, so remember that constants can kind of just stay there, and then we take the derivative of like what's next to it. So the derivative is going to be 3f prime of the inner function, so 4f of x. And then I have to multiply by the derivative of the inner function. So the inner function here is this 4f of x. So if I take the derivative of that, it's just going to be 4f prime of x. So we've got the outer times the derivative of the inner times the derivative of the inner, I guess you can call that. So now that we have this, we want to plug in f prime of 0. So I want to do this and have f prime of 3 of f of 4 f of 0 times 3f prime of 4f of 0 times 4f prime of 0. So because we know what f of 0 is and what f prime of 0 is, we can kind of figure these things out. So f of 0 is 0. So this here is 0. So if I multiply 3f or 3f of 0, that's just going to give me 0. So this is really just saying f prime of 0. And then I'm going to look over here. F of 0 is 0 times 4 is 0. So what I really have here times 3f prime of 0. And then here times 4 f prime of 0 is 2. So f prime of 0, this is 2. And then we're multiplying that times 3 f prime of 0, which is 2. And then here we had the 4 times the 2, so we had 8. So now if I multiply this together, I end up getting 96 as my answer. So it looks more complicated than it is, but you just want to think about the chain rule and do it piece by piece. Another way that we can look at these functions is to look at a table of values here. So the functions f and g have continuous second derivatives. The table above gives values of the functions and their derivatives at selected values of x. So here we have x, we have f of x, f prime, g, and g prime. So they're saying let k of x equal f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. So it's asking for the equation of the tangent line. So what that means that we have to do is first find the derivative. So k of x, if I'm trying to find the derivative, so k prime of x, I'm using the chain rule. So it's going to be f prime of g of x times g prime of x. So I'm going to use my chart to kind of help me here. So I'm doing it at x equals 3. So I want to find k prime at 3. This would be the derivative or the slope of the tangent line at 3. So I'm going to do f prime of g of 3 times g prime of 3. So we've got f prime at g of 3. So I'm going to go to g of 3, and that's 6. So I put a 6 in here. And then g prime of 3, that's 2. So I'm doing f prime of 6 times 2. F prime of 6, that's 5. So 5 times 2 is equal to 10. So 10 is my derivative at 3, which is my slope at 3. And if I want to find the equation of the tangent line, I need to figure out at 3. So I have 10, oops, y minus the y value. So since we're trying to find the line tangent to the graph of k, and k is f of g of x, I've got to figure out the point I'm using. So if x is 3, f of g of 3, I'm going to figure out what this is. This is going to be what k of x is. So since they didn't give me the point, I need to figure it out. So g of 3 we know is 6, right? So we're using 6. So what I'm really doing is f of 6. So f of 6 is 4. So what that means is the point I'm using is 3, 4. So when I go to plug it into point slope form, I have y minus the y value, so y minus 4 equals the slope, which is 10, times x minus the x value. Okay, so we could leave it like that, and if we want to solve it, we've got 10x, and then we have minus 30, and then we add 4, so minus 26 if we're solving for y. Okay, and then the last one we're going to look at is when we have a graph. So here we have a graph of g of x and a graph of f of x. So given the graph below, if u of x is equal to f of g of x, find u prime of 1. So again, we need to use the chain rule. So I'm going to find the derivative of u. So u prime of x is going to be f prime of g of x times g prime of x. Okay, and since I'm doing this at 1, u prime of 1 is equal to f prime of g of 1 times g prime of 1. I guess I should have written that below. Anyway, so I'm going to do u prime of 1 equals f prime. So g of 1, I'm going to look at my graph. Okay, here is where I have g of 1, and that value is 2, times, g prime of 1. Now g prime, when I look at the graph, that is looking at the slope. So at 1, the slope of the g line I can see is 3, so times 3. F prime of 2 means I'm looking at the slope when f has an x value of 2. So here's right here, right? That's where x is 2 on the f graph, and I want to find the slope at that point. So the slope at that point, if I count the slope, is negative 2. So here we have negative 2. That's the slope when x is 2 on the f graph, and then we're multiplying it by the slope of the g at 1, which we said was 3. So overall, u prime of 1 is equal to negative 6.